Thank you all very much for the invitation. Usually my talk tends to be very fast and very extensive, but because I got this terrible cold yesterday, you're fortunate it's not going to be long and it shouldn't be fast. So I'm just going to talk about the ICAP theory because then I would like to collect information from all of you. So if you apply it anywhere at all, feel free to just email me. You know, I always read my emails because I'm curious to know how it's being used. And eventually we're going to set up a website that will contain all kinds of resources. Whenever I hear about something that we can put it in as a kind of resource. So let me just start. So ICAP's a theory about how students learn by how they engage to learn. So teaching by telling or lecturing is the predominant mode of instruction because teaching is assumed to be the delivery of content knowledge, right? That's what teachers think. They have to deliver this content knowledge, although the content knowledge is already in various textbooks and everything. And certainly that's the assumption in college classroom, and lecturing occurs very often, over 55% of the time for college STEM classes, which is what I like to focus on, the science, technology, engineering, math, and medicine. And more than 62 to 65% for online learning, as you can imagine. So the problem is that students don't learn as well when instructors lecture. The most persuasive evidence comes from a meta-analysis of 225 studies in college STEM classrooms. This is published in the National Academy of Science. In fact, the day that this paper came out, I got 3 emails telling me this paper came out. It's really relevant. So what this meta-analysis shows is that if you were in a lecturing classroom, which is simply called passive learning classroom, and we translate the effect size, which is 0.47, you could say the learning outcome is 50%. But if you're in a non-lecture classroom, which the field calls active learning classroom, that goes up to 68%. And the failure rate shows the same finding, which is that if you were in the passive learning classroom, if failure rate is 34%, and that reduces to 22%. Now, this failure rate is really important because what I'm told is that when a student fails their first science courses, they almost never go back and take another science course. So basically, they're no longer STEM majors. So that's a pretty serious problem at the college level. So if the learning is so effective in active learning classroom, why isn't active learning implemented universally in all classrooms? The main problem that I've identified that's out there is what I think is out there is that the current default definition of active learning classroom has no lecturing. It's not prescriptive. That is, there's no concrete definitions of what an active classroom is and what you need to do to implement an active learning classroom. They're often assumed to have lots of physical activity, especially for K-12, and a lot of hands-on and a lot of collaborative activities. But as you will see later, that doesn't really optimize learning. Sometimes it doesn't optimize learning. So to solve the lack of prescriptive problem, I proposed a theory of active learning based on how students learn, called ICAP. So I'm an interdisciplinary scholar, so I'm both a psychologist and an educator. And how students learn in psychology typically refers to students' thinking processes, right? Which cannot be observed, is very small and occurs very quickly, rapidly. But what we need to focus on is overt, visible engagement behaviors as a proxy for thinking processes so that ICAP can provide concrete definitions for teachers and instructors to facilitate and know how to implement active learning classrooms. So that's the hurdle. How do we come up with concrete definitions when thinking process of how people learn is really invisible and opaque? So ICAP's key insight and assumption is that perhaps students' thinking processes can be classified into 4 categories that may correspond to 4 types of visible engaging with instructional behaviors, along with their visible outputs. In other words, lots of processes going on, right? And instead of thinking about all these learning processes that are going on, we simply classify them into 4 types and then see if we can map these 4 sets of thinking processes to 4 discrete sets of behavior engagement. So that was a supposition. So therefore, once you have visible engaging behavior with instructional behavior, along with the visible outputs, then these things become visible and concrete for teachers to use. So engaging behavior in general refers to what students overtly do, say, or write, along with what they produce during instruction. You can use the word engagement behavior with other nouns. You could say how well are students engaged with school. Well, that means you would measure that kind of engagement in terms of how often do they attend school and how often do they do their homework. We're talking about engaging with the instructional information as it comes in while you're learning. So we're looking at the process of learning. What do you do with your behaviors? So the acronym ICAP stands for, you probably know this, interactive, constructive, active, and passive. And it refers to 4 overt ways or modes that students can interact with instructional materials. Each mode can be characterized by the physical behavior and the outputs produced, as shown in the next few slides. The next few is going to be examples of these modes that we have find to be more or less discrete. So the passive mode is simply paying attention. That's like listening to a lecture explanation, watching a video, reading a book sometimes. With no outputs produced, you're watching and listening to a lecture, but you don't write and take any notes. So passive mode, unfortunately, has been the main goal that teachers and instructors want to achieve. They would like their students to pay attention. And you'll see in a few seconds, a passive mode is probably the least best mode for learning. The next mode is active mode, which means you're manipulating instructional materials such as highlighting sentences, underlying sentences, copying from a laptop, copying from the whiteboard. The outputs produced is a part of the original inputs. Therefore, you're not adding any information beyond the instructional inputs. Okay, so you're just manipulating. A lot of hands-on activities are just manipulating. The constructive mode, that's the most important one, I think, is you're actually generating some new information, such as you can be drawing concept map or you can be taking notes in your own words. And the outputs produced contain information beyond the information provided in instructional inputs. They're not new in the sense that they're new to the content domain. You didn't invent new something new to add. You're just making some inferences, just infer something else that could be true about the materials that wasn't presented, and you're just adding that information. Okay. Finally, in the interactive mode, we define it in a very specific way. That is, you have to co-generate with a peer, such as debating with each other and co-editing together. So co-generating means that each partner's outputs, or when they're speaking in a dialogue, must not only be informative beyond the instructional inputs, but also beyond the partner's outputs. So there's 2 beyonds. So this is a very high standard to achieve in order to be co-generative. So unfortunately, about 80% of collaborative dialogues are not co-generative. I'm going to show you some samples of possible alternative dialogue patterns with one partner 1 and partner 2. I'm only looking 1 turn per partner. So the 3 main dialogue patterns is that the first one is that one partner dominates. Okay, so you've seen that when 2 kids work together, one partner dominates. Now, since we're looking at a single turn of dialogue patterns, partner 1 could make a constructive comment and partner 2 could make an active or passive comment. Partner 1 could make an active comment and partner 2 could make passives. So you can see various permutations. But the most important thing is whichever partner dominates and makes the important constructive comments, that partner learns the most. The second is typical divide and conquer, which is really no collaboration. The 2 students agree to divide the task up and they do different parts, and that's really no collaboration at all. There's no interaction at all. And each partner in particular can work either in a constructive mode or both work in active mode and other permutations. And finally, there's a common pattern working in parallel. Again, there's no collaboration. That is, I'm going to work on it myself. You're going to work on it yourself. And again, each partner could be constructive or active. So you can see that I can generate many potential dialogue patterns for each dialogue turn, and they're not co-generative. So because of this, it's very difficult for good quality interaction or collaboration to occur, right? It's really hard to achieve the right kind of interaction. So that's a huge challenge. And what, moreover, in a classroom, it's very difficult for teacher to detect whether good collaboration is occurring. With the language detection system is not strong enough to be able to do that just yet. So what we're going to do in our project, we're probably going to develop a tiny little training system that's targeted at the students themselves to teach them how to collaborate in some co-generative way. So that's a research project within the Eden project that I'll be working on. So turns out the process of thinking processes have a subsuming nature. That is, this set of processes, like if you're making inference, your inference has to subsume the activation process. You activate prior knowledge. So based on the subsuming aspects of processes, as well as the behavior, I predicted that learning would decrease from the I, C to A, the P in the ICAP direction. So again, to repeat what we said earlier, the I is greater than C means that I is greater or equal to C, means that I is greater than C only if collaboration is co-generative. Otherwise, I is equal to C. Sometimes an I could be less than C, okay, because both partners are active. The C is much, much greater than A means that the constructive mode fosters deeper understanding, while the active mode only fosters shallow understanding. So I'm going to show you the next two slides from an old data on self-explanation that I collected to illustrate why I'm able to say that being constructive generates deeper understanding. Okay, so what I'm going to illustrate is students learning a passage about the human circulatory system, about the heart, the human circulatory system. It turns out, so this is an interesting fact by itself, that most text passages are incomplete with missing information. We looked at the best textbook in biology, most commonly used, and we look at the passage about the human circulatory system. Every passage has missing information. They vary in what they miss, but they all have different missing information. This in and of itself tells you that you cannot make this instructional information perfect, right? You need the students to construct their own understanding by making it perfect. Anyway, so the analysis we did for this biology text is the structure, behavior, function. So what you notice in the yellow is that when they talk about the atrium, they didn't talk about the function. When they talk about the valve, they didn't talk about the flap, that it behaves with flap tissue. So for different components, different pieces of information is missing, right? So what we did then, we designed assessment questions based on what information was missing from the textbook. So all in all, there's like 11 pieces of function information. Function information is a very important piece of information. And we designed assessment questions so that you needed the function information in order to answer the question. Okay, get that? So in these function information is omitted from the text, but in order to answer some questions, you need to infer the function information before you can answer it. So those questions obviously are difficult questions because you need to make those inferences. Okay, so up here I said we asked them to read a passage. So the blue line shows the explainers, we asked them to read this passage, and we said, try to make sense of the passage and explain it to yourself, whatever sentences you don't understand. We call that self-explanation. And what the blue line shows are the people who are more frequent at explaining. They spend more time uttering self-explanations that make sense. I mean, these are all segregated based on some unit analysis, so we can compare them. The red line shows the people who explain a little bit less frequently. And on the x-axis are the question types. The one on the left is verbatim questions, which are easy. Second set are integration questions, which is medium. And then the inference questions, which is most difficult. So what you see is that for the most significant differences occur in the most difficult questions. That is, for the high frequent explainers, they learn the most, significantly more on the hardest question. But in fact, there was no significant difference in their performance for the shallow questions. So for the easy question, you don't need to do a lot of self-explaining in order to learn. Okay, so this result shows very clearly, and there's other results as well, that the benefit of being generative is you get deeper learning. So ICAP is evidence-based, and what do we mean by that? What we mean by that is that predictions are supported by hundreds of studies out there already that's published. Okay, these studies didn't know anything about ICAP. I was just able to reinterpret all the results in terms of ICAP, and I get a simple, uniform interpretation for all these studies. So let me just give you two examples. So one study is people have one condition where they have students correct the concept map. Well, that's obviously constructive, compared to reading a text on the same topic, which is passive. And they show that correcting a concept map is much better than reading a text. I mean, I did the same thing too. I compare self-explaining to, in fact, reading the text twice. You can read the same text twice, and self-explaining is still better. So I did the same kind of study back then. Or another example, you could be studying an incomplete example, that is a worked out solution example with missing steps, right? And you learn more than if you study a completed example. Okay, these results all seem, not only are they seem counterintuitive, but the author then wants to push their activity. They say, oh, studying incomplete example is the best thing to do. That's what you should have students to do. So everybody is suggesting what their activity is the best. But in fact, their activity is just an example of a constructive activity. For you to really, truly claim that correcting a concept map is an excellent strategy, you need to compare that with another constructive activity, such as studying incomplete example. People don't usually do that. They usually compare to a passive activity or active activity. So basically, my point is only that you cannot conclude that correcting concept map is really a great task for students because you're not really comparing it with the right control condition. Moreover, all these results can be explained by ICAP's predictions. Okay, so ICAP can explain a lot of these studies out there that's really powerful, and applies to even 5-year-olds. It applies to children, very young children reading textbook and things like that. I didn't include a 5-year-old study, but I can explain to you if you want to know that. So what I wanted to show is a major dissertation done in my lab where we actually we had 4 groups of engineering students, and we put them in 4 conditions corresponding to the 4 modes. Because most of the studies out there only compare 2 modes, right? So the first mode is they just read this text, I think about atomic bonding, a big paragraph. And then the second condition, and the active condition, they read and underline. And the third condition, they explain actually a graph that doesn't say anything, but they had to explain it for some outcome. I forgot what it is. And then finally, they explain with a peer. So they all got the same pre-test, blue line, and same post-test. And for each condition, there's significant difference from pre-test to post-test, meaning that everybody took the task seriously. They didn't fluff it off. They all learned significantly. But more importantly, from condition to condition, there's an additional advantage, right? So from passive to active, you gain the post-test gain another 7%. From active to constructive, it gains another 11%. And then for interactive, it gains another 9%. So altogether, there's 27% difference between active and passive. However, most of the studies out there, when they don't have 4 conditions, or when they implement an active classroom, the difference in passive and active is only around 10%, including the latest paper that was just published in Nature about calculus. So my point is only that active, constructive, interactive are all considered active learning classroom. whereas passive learning is just this one mode. So really, it's really active and passive learning. It's not binary. And most importantly, as I was saying about the calculus study, it seems that a lot of active learning classroom is missing the important constructive component. This is just not enough of it. Okay. Okay, check your understanding. We have two peers. One is giving an explanation. The other one is receiving explanation. Which peer learns more, the one giving explanation or receiving explanation? Who says giving explanation? Okay, this result was found by Noreen Webb, over 20 decades ago, 2 decades ago. And people just couldn't explain it. It seems so counterintuitive. How could you be giving explanation and learn more than if you were receiving correct information? Okay, check your understanding again. Is there an advantage of interactive collaboration due to each person in the group having different relevant pieces of knowledge? Yes or no? Yes? No? Okay, the answer is no, but a lot of research thinks that, or they design their research so that different person has different pieces of knowledge, so they get together, they can solve it. I have the equations, I have the whatever, then I can say, well, obviously, if you don't have the right knowledge, you can work with each other and get something. But collaboration could be so much more powerful and creative, actually. I don't have a slide to show. So what it is what makes it possible to be so creative is that the inference mechanism is going on. So I'm talking to you. I made an inference that you didn't make, but you can build on my inference that you didn't know about my inference that you didn't make. So eventually we can come up with something very creative that neither of us could have done. So there's really potential for collaboration, but it's hardly ever carried out the correct way. Okay, now I'm going to translate theory into practice, some of the work that we've done. Others are potential application that we're just telling people about. Because what we really want to do in the Udemy project is develop professional development about ICAP to teach it to students, to teach it to faculty and teachers, and help them implement more active classroom, more effective active classroom. I'm going to give you 8 examples this time. So the most important example, which could be the simplest example, is what I call mind the verbs. I love the phrase mind the verbs. We don't say that in the United States, but when I was in London for one of my conference, when you take a subway, they constantly say, mind the gap, mind the gap. So anyway, I used to mind the verbs. So this is a study we designed. This is actual study we did where we tried to train teachers or taught them about ICAP and ask them to change activities to what we call upgrade them. If you had an active one, change it to a constructive one, and so on. Anyway, I'm not going to go into details about a study, but the point is, when you design this instruction for students, you have to tell them what to do, right? And when you tell them what to do, you have to have a verb. So you might say, review the feedback, match similar ones, make up your own reasons, and exchange ideas as appear. And it turns out all these verbs could be classified easily. So that's passive, active, constructive, interactive. So we just went and classified all these verbs. And it was very simple to classify. We now have I have about 60 per column. So for the left column, is the verbs more generative? Is it generative? The left column. No, you're right. It's more manipulative. See, so you can just tell. I mean, there's only a few verbs where you have to look at the words, the following words. Like if you say connect 2 ideas, that might be different than connecting the wire to 2 wires. There's only a few words that are different like that. So now we have these sets of verbs that we can use that's clearly active or constructive. So here's the application potential. Turns out an instructor and teacher can easily upgrade the ICAP mode of student activity by simply changing the verbs and, maybe the pictures too. So we have 2 classroom examples where the change is actually identical. The modes of change is identical, but one's at K-12, one's at college level, just to show you the applicability. Now, this K-12 teacher and ASU professor, They both learned about ICAP, but I didn't direct them in how they should make these changes. They just did it, okay? There was no input or feedback from us. So the first one is very common. The one on the left is a typical active activity. You ask the kids to pick among these answers and fill it in, right? You really choose the equivalent. So that's active because you're not adding in new information. And the teacher modified to the constructive activity on the right, that is to create 3 equivalent representations. So this change from choosing or filling the blank to constructive is a very, the choosing is very common activity. So this upgrades it. Now I'm going to show you the same kind of change from an engineering professor. So here's one activity the engineering professor did at the college level where you have to fill in the blank on top by choosing the properties to change, the unit cell transformation, and so on. So you just, same thing, you just choose the option it's given you. And after he learned about ICAP, he changed it to explain a Java version. So you're not choosing, instead you have to explain the original processing method and so on. Very simple change. Okay, I'm going to give you a second example. The second example is a recent PhD dissertation that was done in our school. I'm on the committee, where Jesse's using the ICAP modes to evaluate lesson plans. Okay, and what he's doing is he's took these chemistry online courses, look at the lesson plans, and allocate how many minutes is allocated to an active activity, constructive activity, and so on. So as you can see across these things, about 1630 minutes and 2490 minutes total were devoted to active and passive activities. There's hardly any constructive interactive activities. Right? So 80% of the time is spent on shallow ways of learning. And this is a chemistry course. So ICAP can be used as a coding scheme, and that's one of the most popular way it's been used in the literature so far. Okay, here's a third example, that if you understand ICAP, it can prevent adverse changes to digital tools when you use these digital tools. So a very common tool is clickers in a classroom. So clickers in a classroom has 5 components, right? You answer some questions, and then you see the bar, and then you, based on what answer you give, you interact with your peer, and then you re-click again. So that's advantageous. It's been written about in science education at the college level as very advantageous. Well, one of the advantages is because there's this collaborative component. But faculty in general, they want to do it fast. They just cut out the interactive part. So by cutting out the interactive part, they basically reduce it down to an active assessment. Okay, so if you don't understand ICAP, you don't know what you're doing, you're making changes that are detrimental to the tools. Your understanding ICAP can also be used to help select digital tools to use instead of basing it on decision, let's say for the department, on cost, compatibility with platform, ease of use, and so on. Instead, you should analyze the ICAP modes of the tasks there that the students can input. So I just looked very briefly at Echo 360, which is the 2017 version, and look at the kind of activities that the clickers, clicks, and so on that the students are allowed to do. So what I found was they can do play bar to pause the play and rewind a lecture. They can bookmark a location of lecture. They can flag some content, take notes that repeat the content, respond to multiple choice, respond to images, thumbs up, and so on. But which mode are all these activities in? They're all just active. So you want to evaluate this digital tool and say, is it worth spending lots of university money buying this for the whole university, when all you get is active out of it? Okay, people always ask me how to improve their lectures. So the misconception, especially when I talk to medical schools, is that they think medical schools are very divided. They like teachers, the faculty either do problem-based learning, which is a complicated thing, or they do lecture. And there's just no agreement, and nobody wants to move the method. So what people don't understand is that you can improve your lectures in very minor way, cheap way, and you can preserve your lecture Faculty, after they've been teaching for many years, they're never going to change your lectures, right? But you can improve it by doing these little things. Instead of, for example, instead of improving the content, the clarity, the organization of a lecture, for example, when I have attended PD, people will say, start off with a story to get them build interest, provide keywords, subheadings, all these ideas. But none of these are in the way that ICAP can improve a lecture. So I can improve lecture by just inserting pauses, ask students to reflect, ask students to generate the muddiest point, which there is a lot of data showing is very effective. Ask students to find errors and incorrect solutions. Basically, all these little tricks, all these little techniques takes very little effort, so you can modify your lecture in very minor ways and get some advantages. One point about frequency. Remember in the self-explanation data that I show, it seems like the more frequent you make changes, the more frequent you're constructive, the more you learn. That's because if you're being generative, what you're really doing is changing your mental model, right? Changing your knowledge, you're revising it, enriching it, and everything. So frequency really does matter. So the more often you ask students to reflect, probably the better. Finally, not finally, one next to last, how do you choose a learning activity among the plethora of, we love that word, available based on its ICAP move, rather than choosing based on its complexity and time commitments? That's what people think about. How complex is this activity? I wrote a couple there, or how much class time commitment do I need? And so, but based on that, you choose an activity. Instead, you should choose an activity based on ICAP. So we've got 20 activities here. With this criteria, these are all active ones. For example, I just made it bigger. You can read a ranking. There's an activity called rankings, rank all kinds of stuff, testing and retesting. So these are all active activities that you can pick and choose, right, based on the ICAP mode. These are the kind of things we're going to put on our website when we are ready. Or there's lots of constructive strategies. Again, you can pick and choose which one you want to use. You could be doing critiquing something, or you could be debugging, troubleshooting. So once you know, you can pick it based on the ICAP mode. Example 7. So you can use ICAP mode to evaluate teacher skills. This is something we haven't done. I mean, we've done the basic, but we haven't actually gone out and evaluate teachers. You can code a video, or you can code a transcription in real time. So this is different. This is a lot more work than Jesse Haas' work, where you just evaluate the lesson plan. This is more, you can evaluate when the teacher's actually teaching. So one thing you can evaluate is how well do they lead discussions? What kind of questions do they ask? So this is a much more fine-grained analysis of a teacher's leading discussion skills than just saying how many minutes in that class that they devote to leading a discussion. This is about what kind of questions did they generate, okay? So this is much more sensitive. Let me give you an example. So again, there's 4 types of ICAP classified questions. The passive questions are things like getting approved consensus, like humans can't live on Mars, correct? So this is a passive question because the question just asks for confirmation. Active question might be something like, which planetary body are humans more likely to be able to live on, Mars or Europe? And you have to select one of the answers that's already given to you. We already said that's active. Similarly, with questions just like, describe what we talked about yesterday, which asks students to produce information, but not beyond. Okay, these are clearly, you can clearly decide what kind of questions these are. You can also have constructive questions, of course. Why do you think humans can't live on Mars? So this is constructive because students have to provide an explanation, assuming that the question has not already directly answered in the course. What will happen to the mice that have the mutation described in the text? Again, requesting information beyond. And then there's interactive question, which is pretty simple to generate, like what's wrong with Nicole's ideas on why human can't live on Mars. So it's interactive because you're asked to build on other students. So my point is that these 4 modes of asking questions are very natural. The context dependent, is they're embedded in the content that you're teaching. as opposed to following a very strict script, right? Like you got to use these keywords, like in accountable talk, you have to do revoicing, you got to do repeating, you got to so on. Whereas this is just very natural. You know, as a teacher, what content you've already introduced. Therefore, you know whether the student, you're asking students for something extra beyond. So the conclusion of the application potential, there are many more application possibilities. I really want to hear about them. Some have been published, others have not been used by practitioners, and others are ones we propose, but we haven't implemented. And other potential and generate from participating in the summit. So let me know if you are applying ICAP in new ways, even if you haven't published it, just tell me how you're doing it, because I wanna hear about your effort. Okay, so in summary, ICAP is a parsimonious theory. It's a simple theory of how students learn, and yet it's very powerful because it generalizes across domain, context, age, and different activities. It's prescriptive with concrete operational definitions that about overt behaviors and output that teachers can look at and think about. It differentiates shallow versus deeper learning, so it's particularly good for STEM domains. And it can be translated to a theory of pedagogy in a sense and uses a tool in various ways. So that's all I have right now, and I put here 3 questions that you might be curious about that we could talk about. So one question is, there's many more open questions that there hasn't been research on. So one open question is, what proportion of a class should be passive, constructive, and so on? Iris asked that yesterday. I don't know. My guess is probably depends on the content of the class. So as you know, not all domains need constructive, right? So what kind of content domains do not need constructive? Does anybody have an idea? The contents you don't need are domains that you cannot elaborate any further. So my postdoc of several years ago did a dissertation where she developed a little technology tool to teach immigrants how to, say fill in with grammatical verbs and languages. And she couldn't get any advantage from self-explaining. Well, that's because for a logical, or in that case, may not even be logical, domains, there's nothing you can explain to elaborate it. You just have to memorize, okay, when this, I add S. When this happens, I add T, right? So for those kind of domains, you don't need to be constructive. Just active is what you need. So there are domains, so you just need to be active. Okay, another very important question, which there's not enough research on, is, are sequencing important? So what do we mean by that? That's like passive is great if it's followed before or is preceded by a constructive activity, right? So there's an article by Dan Shorts called Time for Telling that was published a long time ago, and that's compatible with this. What it means is that when you give somebody a constructive task, they worked on it and they probably find things they don't understand. So they created these empty slots, call them empty slots, that seek that information when it's presented. So you're priming yourself once you're constructed and fail to have some new input that fits it. I mean, that's one explanation. So sequencing is very important, but we don't have enough data, hardly any studies out there. Oh, this is very important. Typically, generative activities are not given feedback, right? When you self-explain, nobody gave you feedback. And in fact, 25% of self-explanations are incorrect. Is that a problem? No, it turns out it's not a problem for a couple of reasons. One is that if you generate something incorrect, ultimately you'll see something in the text that contradict what you already know. So creating that impasse or conflict might actually allow you to learn faster, right? But we don't know whether giving you feedback after generative activity is actually helpful. I mean, I just don't know about that data, whether it's out there. So I don't know about that. But the fact that you can benefit from generative without feedback is really great, because then you can use it in online learning without the need to constantly give students feedback. Anyway, those are the 3 questions I've addressed and talked about, and I'm done.